This is All Things Ansys, a podcast from the technical support staff at PADT. Episode 133. Our Ansys support team weighs in on their favorite features in Ansys 2024 R1 and R2, plus news and events from around the world of Ansys. Greetings and Happy New Year. I'm Eric Miller, one of PADT's 3 owners and your host for these podcasts. I am recording this from a hotel room in Tucson, Arizona, because PADT and Ansys are at the Arizona Photonics Days conference here, a week before Photonics West. Today was great, and I learned that my knowledge of optics is not deep, but I really do find it fascinating, especially today we talked a little bit about astronomy, and it's just so cool. For those of you who don't know, Tucson is a center for optics and photonics in the U.S., based around the School of Optics at the University of Arizona. PADT has always been involved with the industry through 3D printing and doing mechanical and thermal simulation for optical applications. But after the acquisition of Zemax by Ansys, we got even more involved. It's a great conference. It's very technical, and I can't wait till tomorrow when we get to talk a little bit more about quantum networking, and a few more of the astronomers are going to come and talk about their cameras and their mirrors and their lenses. And then best of all, on Friday, we get a tour of the lens manufacturing facility at the University of Arizona, where they make the huge, giant, massive reflecting mirrors. So looking forward to that. So anyway, enough about optics. We are here in the new year, 2025, 1/4 of the way through the 2000s. Kind of mind spinning when you think about that. Yeah, 25% through 2000s. We look forward to spending this year with you, and hopefully we will have an opportunity to spend more time with some of you as a partner this year, either doing work with you or supporting you or helping you get Ansys, whatever it is. So we hope to work with more people this year. And as we finish, 2024 and start 2025, we wanted to look back on 2024 and specifically what came out in Ansys 2024 R1 and R2, and share what, after a year of usage, our team really liked. We really wanted to take a look back. So we're lucky enough to get a large number of our Ansys technical team on this discussion. So please join us and see what everybody has to say. Alrighty, thank you. I want to thank our team and those of you who are listening for joining us today for a discussion on Ansys 2024 R1 and R2 in review. So, a lot of times on these podcasts we talk about, we just got the new release, we're really excited about it, we think this is going to be cool, this is going to be cool, that's going to be cool. Well, now we've been using it for a while, and our customers have been using it for a while. So now we kind of know what's really making a difference and what we should get excited about. So that's the point of today's podcast. We're joined by a great collection of our members of our PADT's Ansys support team, and we may have some people come and go as well in the discussion because they're answering support calls. So we may do that. But let's go ahead and start with some introductions. I'm going to go alphabetically. So Alex, why don't you tell our listeners about yourself and what you do here at PADT?
Sure. My name is Alex Moody. I've been an application engineer at PADT for 3 years now. My background is electrical engineering, and I worked in the wireless and defense industries before coming to PADT. And what I represent is I really represent the entire Ansys portfolio that revolves around high-frequency electromagnetics. So that could be antenna design, that could be signal integrity, power integrity, EMI, EMC, things from printed circuit boards to satellites, anything that involves high-frequency electromagnetic phenomenon.
Great, excellent. Well, Christian, how about yourself?
Yeah, my name's Christian Crowley. Just like Alex, I'm an application engineer here at PADT, been so for 2 years. Unlike Alex, my specialty is not in electronics, but in structural mechanics. So before I came to PADT, I worked in the tire industry doing simulation on tires, so nonlinear, hyperelastic material, things like that. I wouldn't say that's necessarily my specialty. My goal is just to be well-versed on all the wide variety of the structural topics. So, maybe that's like composite windings, maybe that's an additive simulation, maybe that's just like plain old like static structural mechanics of a steel structure. Anything that could be talked about in terms of like stresses, deflections, materials, that's what we do.
Excellent. Very good. Well, Doug Oatis has joined us. Doug, why don't you share with the team what you do here at PADT?
I'm glad I joined muted because you were just starting the recording, so I was going to come in hot. So that was a good thing.
That's a good thing.
Yeah. I guess I'm now an old Ansys user. I thought that I knew the day would come. So I've been using Ansys since 2003. So I'll lump myself in the APDL generation. Maybe I was
Yes.
like the last of the APDL
Yep.
generation. So I've been at PDT for 20-ish years. I think I don't think I have a plaque that says it, but we'll call it that.
Yes.
And I used to be an AE. I'm kind of more on like the sales liaison role, so working a lot of sales engagement. So when I get to use the software, it's kind of quaint. And so I've seen a lot, and so but my heart is on the structural mechanics side of it.
Great. Excellent. What I forgot to ask is if you let people know where you're calling from. So, Doug, I think you're in Denver right now, yeah?
Yeah. I'm back in Colorado.
Yeah. And Alex, where are you calling from?
Knoxville, Tennessee.
And Christian?
Denver as well.
Great. Excellent. And Daniel?
Hey, yeah, I'm in Austin, Texas.
Great. So, why don't you share about yourself as well?
Sure. Yeah, Daniel Chaparro. I'm one of the CFD application engineers, so fluid dynamics, supporting anything that works on fluid physics, right? Cooling, heat transfer, chemistry, turbo machinery. A lot of different industries. My background is primarily in aerospace, and I've been with PADT for about 5 years now. So,
excellent. Very good. Cool. And Molly is new to the team. She's not new to PADT, but she moved from the consulting team over to the support and application engineering team. So, Molly, why don't you share about yourself?
Yeah, I'm Molly Rhodes. I'm calling in from Tempe, Arizona. I'm an application and support engineer for mechanical and thermal products under the Ansys umbrella, mostly Ansys mechanical and thermal desktop, but I kind of dip my toes into other mechanical related products as well.
Great. Excellent. And Noah?
Hey, I'm Noah Asherbranner. I'm another application engineer working primarily in the model-based systems engineering domain. I've got a background in robotics and autonomous systems, and I'm calling in from the greater Phoenix area.
Great. Excellent. And Robert McCathren?
Hey, so I'm Rob, and I'm calling in from Houston, Texas. I represent kind of the mechanical and the discovery and the materials engineering side of Ansys products. So you may know that as the Granta's selector and etc. But I handle that. My background is in structural mechanics. Did a lot of naval architecture and stuff in a previous life.
Good stuff.
Rob, you forgot acoustics.
Oh yeah, I'm now that, yes.
Yeah, I heard that. I heard that you were working on acoustics. Get it? Heard.
Yep. Oh man.
Gotcha. Sina, steal it away, please.
Yeah, hi everyone. I'm Sina. I'm with PADT for 7 years, more than 7 years now, almost 8 years. CFD application engineer. My background is also aerospace. My area of expertise are combustion, multi-phase, and I mainly work with aerospace companies these days.
Great. Excellent. And last, because it's a T, Tyler.
Hello, my name is Tyler Buntin. I've been an AE at PADT now for almost 2 years. I've been using the Ansys software for almost 10, so we're getting up there. My background here is mostly all across the EM spectrum, but focused mostly on low-frequency electromagnetics here at PADT. Before coming to PADT, I was mostly doing research, both in my advanced degrees and then also for various research firms. And those topics range from magnetic diffusion to high-power microwaves to motor design. So I've covered the spectrum of it, but focus mostly on the low-frequency EM.
Excellent. Very good. Well, and Joe Woodward may join us if he gets off that call, but Well, one of the reasons why I wanted to know what you guys did and where you're from is to kind of highlight the diversity of our support team and our application engineering team here at PADT. So, we're not all at the PADT's main offices here in Tempe. We're kind of spread out all over the place, and we're not just a bunch of mechanical people or fluids people. We've got kind of the full spectrum, and we've got an optics person on staff who's with a customer, I think, today, and other physics that Ansys covers as well, but and Elestina and things like that. So anyhow, wanted to make sure everybody listening kind of knew how broad our bench was here. I'm not a sports analogy guy. Is it deep bench or broad bench? It's probably deep bench, right?
Deep. Yep.
Deep. Okay, thank you. So let's go ahead and get started talking about.
This might be the wrong crowd to ask that.
I was to say, you guys did take a while to answer.
Thank you, Noah.
I feel at home. So let's start. I mentioned fluids. Let's start with fluids. We have a lot of users that use Ansys, Fluent, CFX, some auxiliary products around them. Anybody want to kind of jump in and talk about in this last release, 2024 R1, R2, what you found is really people are getting excited about and finding useful?
I can
Daniel
start.
or Molly, that's either of you too.
I can start. I mean, it's the same direction basically as it's going for a few years. GPU obviously is the main object of development for Fluent releases. Each release it gets more capabilities, and the benchmark test results that come out each release is really amazing. It's a no-brainer in terms of cost and power consumption, and obviously the speed of simulation is amazing. It's a no-brainer. That's the future. As I said, each release gets more capabilities. Some beta beta features. The latest release was really exciting. Something that people are waiting for. UDFs, for example. I know combustion is one of their main goals, to have the main power users, aerospace defense industries that do combustion simulations switch to GPU. They're putting together all the needed pieces of the puzzle for that. They added more capabilities for that. Adiabatic flambit is added. Particles are added. So they're getting there. That's one of their main goals. And for turbomachinery industry also, they're adding the turbo space basically in Fluent GPU. So they're all on the roadmap, very near future roadmap to have power users with all the capabilities, CPU's capabilities migrated into GPU basically.
Very, very cool. So those who are listening should be putting a GPU based system into their budgets for the future, or cloud solution that's got access to GPUs, because it sounds like it's going to really pay for itself very quickly.
Yeah, that's right. And they're going the other direction also for people that don't have any hardware, and it's the web user interface version of Fluent is also getting developed. So you can basically launch everything from a browser on the cloud or somewhere else. They're going both directions.
Good to know.
Yeah.
Good to know. Yeah. Yeah, I know that on the consulting side, we've had some really good luck lately running some of the bigger models over on the cloud side of things. So that's been a really kind of a game changer for us to be able to do multiple iterations very quickly in parallel. And yeah, it's been good. Anybody else have anything to add about fluids?
Yeah, I'll go ahead and talk about Thermal Desktop a little bit, since that's under the Fluids umbrella now. One big addition in 24 R2 is that now we have axisymmetric modeling. We didn't have that before, and coming from the mechanical side, axisymmetric modeling is huge because that can save us a lot of time on the solver side, and even helping with meshing. So now that we have that in Thermal Desktop, and we can use axisymmetric models and get radiation calculations and just all the things that Thermal Desktop does, that's huge for solver time. I think it'll really help a lot of customers out, especially in the turbo machinery industry, because it's a big advantage.
Yeah. Have they made any changes to the user interface in Thermal Desktop in this last release, or is that coming in the future?
I believe it's coming in the future. We still
Okay.
use Space Claim for TD Direct, and we can
Okay.
set up mesh tags in there, but I believe in the future they're planning on moving to Discovery in future releases.
Good. Okay. Good to know. Anything else fluids-wise?
Yeah, I guess I'll quickly chime in there. On the meshing side, that's been
Please.
a continuous improvement for Fluent. I think in 24R1, one of the big advancements was bringing in multi-zone meshing into Fluent. So used to be if you wanted to kind of like a pretty much structured mesh, we'd have to do that in Workbench, but now we can do a lot of that same capabilities in Fluent, as well as 2D meshing, which is now available in Fluent. So just continuously improving that tool and then becoming kind of the go-to for all CFD applications. So that's been something that's affected all of our customers, right? So.
That's good. That's multi-zone. Yeah, that's. I remember when it came out in Workbench, it was kind of a big deal, and that's good to hear that it's over on the Fluent side now. So that's really cool. Excellent. Anything else on the Fluids?
Maybe the last thing I add,
please.
optimization is obviously a big.
Oh, yeah.
And Ansys OptiSlang is one of Ansys, probably the main optimization tool in terms of CFD simulations and optimization. And it was actually it's a built-in. There's a built-in version of OptiSlang in Fluent now, so
good to know.
You can run everything inside Fluent. Yep, that's also very useful in terms of consolidating everything into one single tool.
Yeah, very much so. Awesome, cool. All right. Well, cool. Let's shift gears quite a bit. I think I'm going to jump on over to, let's do low frequency electromagnetics first. So what's going on in that area? Of course, very important these days with electrification and efficiency and things like that. And it touches every aspect of our life now. So what's going on in that world?
Yeah, so the biggest updates this last year were definitely electric machine related. So big advancements both in Maxwell and MotorCAD for that. Some new simulation methods to make the process a little bit easier. That was probably one of the biggest ones for electric machine design. In order to reduce numerical noise, and previously you'd have to align your mesh with your time steps so that you're not missing data, because your machine's going to rotate in terms of degrees there.
Right.
So you have to keep that in mind as you're doing it. But there's new meshing or sort of optimizations that Ansys has done to improve that simulation method. So that's something exciting, and going into 25R1 is something they're expanding on even more. And I'm looking forward to seeing how that continues to improve.
Yeah, I bet. Yeah. That's a big change. Yeah. Nice. Cool. Anything else worth noting?
So for 24R2, another big one that did come out, it's a little kind of a silly feature, but a very useful one.
Right.
There's a tool called the Fields Calculator, where you can input various field quantities and calculate values that the software doesn't automatically calculate, but you have all the data to calculate. And previously, you'd have to use a calculator that was in a notation known as reverse Polish notation, and so learning that is a bit difficult.
As an older person, I used to use reverse Polish notation. Funny enough, I had a discussion with a college student last night about it, that he has no idea what I was talking about. So yes.
So yeah, that's required to use the field calculator. But going into 24R2, they added as a beta feature, a way to do expression-based input, so you can just type what you are looking to resolve, and that's supposed to hopefully expand to the rest of the ADT suite. It's only implemented in Maxwell currently, but hopefully continues on from there.
That is good to know. That's so funny. What a small world. We were just talking about reverse Polish last night and how we used to think in that way, but now it's lost. So good they're making that switch. Yes.
Yeah, big advancement.
Yeah, good. Okay. Anything else? I think the obvious next one to talk about really is on the high frequency side. So in that whole product suite of HFSS and all the other products, what's the most exciting thing out there right now?
In my opinion, the most exciting thing is HFSS's new beta features that came out in 24R2, and they're all related to antenna arrays.
Okay.
So for those in the audience who may not know, an antenna array is just a collection of antenna elements on a grid. It's just a bunch of antennas that work together, and that allows you to do cool things like electronically steer the beam. So you don't have to mechanically rotate the antenna to point it in a new direction. You just change some stuff electronically, and the beam instantly switches. And that's something that HFSS has been doing for many years now, but what they added in these last few releases is the ability to mount your array on a platform of some kind, because they won't just float in space. They'll be on a cell tower or a vehicle or a satellite. And in the past, you could simulate that, but it wasn't very efficient computationally. So there's a new beta feature that came out that allows you to put your array on a platform in an efficient manner. But that's just one of the new beta features. There's a second one that allows you to have multiple arrays in one design, which is a common need because a lot of times you'll have a transmit array and you'll have a receive array, and they'll be located very close to each other in terms of the proximity, oftentimes on the same platform. So now with these new beta features, you can have your whole structure, the platform and the multiple arrays, in a more computationally efficient way. And of course, there are some caveats for that because they're beta features. But with 25R1, a couple of those features have come out of beta. I'm still kicking the tires to see what all it can do, but a lot of those limitations have been relaxed. So even going forward, these features will be more exciting in the future, I think.
Yeah, good. Very busy little developers there. Yeah.
For sure.
Yeah. Anything else that maybe in some of the other tools or?
Well, we're still waiting for that reverse Polish notation in HFSS. That hasn't come yet. In SI Wave, there's been a number of improvements to some of the more advanced solvers, things like the EMI EMC type of workflows, but nothing as notable or as exciting, I think, as the antenna array.
Yeah, that's big. It's big. Important industry in a lot of ways as well. So we definitely see a lot of it out there. Good, excellent. So that's the electromagnetic thing. And by the way, kind of a side note, I just finished listening to a new biography about Faraday and Maxwell, which was fascinating. Just to kind of see how this whole world evolved between those two men. So highly recommended. If you haven't listened to that, it's kind of neat, the history behind their experiments and their math and how they kind of derived the stuff that you guys, Tyler and Alex, use every day back in the old days. So, all right, let us move over to structural. I think. What's going on in the world of structural these days? What's exciting from this last couple two releases?
I'll go first off the bat here. So I have two things real quick. So I guess two big ones for me are on the acoustic side. Ansys sound is now kind of included within Mechanical Enterprise, so that gets all baked in, and Ansys is making further efforts to integrate all that. And so within there's all those little separate programs on the NVH side. Those are now fully referenced within Mechanical.
Okay.
So they're bringing that more and more into the fold, and if not at least fully in, then hopefully better GUIs and UXs. So that. So it's a good trend. The second one is I'd say it could be a controversial one, but in R1 they introduced prime meshing or prime mesh method. So they're doing away with batch connections. So for things you would use for joining different bodies together, or doing like we have a lot of customers that will do the weld bodies. So you'll do like a kind of like a post mesh operation, like joining and making a weld, and so that affects that workflow. But it also makes it a bit easier because eventually there's just going to be one option instead of the kind of multiple options they had before. So it is now behaving a bit better in R2, and I'm looking forward to seeing it in 25R1 and beyond.
Interesting. Yeah, I'll have to dig into that. That's very interesting. Okay. Cool. Well, anybody else got anything exciting they're excited about in the structural side of things? Thermal, I guess, kind of falls into that product line.
I want Christian to talk about Python stuff personally. That's me throwing him under the bus.
Which stuff was it, Doug?
Python or like some of the scripting automation stuff.
Oh,
and
yeah.
things like that. That's
Yeah.
it's not new,
Very
but
exciting.
it's definitely a continuation.
Yeah.
Of, different.
Yeah. Yeah, I mean, as far as like the specific changes they've made to the Python interfaces, like there's probably too much to say. But they're continuing to just roll out different Pi interfaces for all the tools, like whether that's meshing for your stuff. Like this year, I got to work on Pi Insight a little bit, which is a post processor that's kind of agnostic, mostly used for the CFD regions, but can be used for structural or coupling multi-physics data as well. Even beyond that is Pi DPF, which again, not a new thing necessarily for this release, but ways to actually like crack open the result file and process the data directly from there. So those are a couple of things that jump off the top of my head as far like things that the Ansys is continuing to work on and is pushing out there for people to be using with the automation side of things.
Let me ask you this question, because I've played a little bit with it, and others here have. You have, Alex has, I think others. Is this ready for prime time? Is it something that people listening should really spend some time to learn Ansys so they can automate things and, like you said, get into the result file and do all that kind of stuff? Is it documented well enough and robust enough for that now?
I guess that, I'll kind of like, put this answer in two parts. Like,
okay.
It is still being worked on, right? Like,
okay.
Documentation.
It's a moving target.
Yeah. Sometimes it's frustrating. Sometimes it's fine. I often find that I have to go through like maybe 2 or 3 examples before I'm like, okay, I finally get how to start this even, or what they're really trying to communicate. At the same time, the functionality is all there. I've never been like, I want to do this thing and I can't do it. So as far as like the learning aspect, I think I think they could work a little bit more on the interface, and they've really taken this like open source mentality, which might just be like they're like, well, that's on you to figure it out, and that's fine, right? As long as it's open source. Again, I've never really run into any functionality that's not there. I think mostly what they're developing is kind of like weird bug fixes or maybe making things work a little bit better, but I think it's there. I don't think you're not gonna feel like, oh, this I can't do what I actually want to do yet. Like if you have an idea, an application, I'd say go try it.
Good. That's good to know. Good. I'm a huge fan, and it's just amazing the access you can get into these files and results and things. And if you wanted to make your own post processor, you could. Right? It's all there. Yeah. Cool. What else from a structural, mechanical, thermal standpoint?
One thing I was going to say that I've heard a lot this year, this is kind of like, it's not really a feature, more just like hey, it's nice. Like they added a dark mode. I think that was back in R1.
It's true.
Like the number one reason I heard like a lot of the young engineers upgrading this release, they're like, I want that dark mode, so.
It's true. I definitely agree. Especially you spend 8 hours a day staring at that screen, it makes a difference. Yeah. Good. Anybody else have anything on the mechanical side? Cool. All right. So what did I miss? I'm sure I missed a physics or aspect.
I actually wanted to jump in at this point because like you hit on all these individual physics.
Yes.
And I think the one thing that's become very apparent, like, the past couple of years is just sense of scale, right? Okay. So, 15 years ago is very, part assembly, that kind of stuff.
Right.
But you introduce, thermal desktop versus Fluent versus Ice Pack. Like there's overlaps in kind of functionality there, but each one has its space. And so, previously, when we just had mechanical APDL, like we could only do this. And if you wanted to kind of trick your way into a larger system level modeling stance, like you really had to kind of like think outside the box. And there's a lot of tools now that are available that allow you to simulate more than just your part, right? Like you engineers designing or analyzing something, redesigning something for a specific part, but you actually need to think bigger, right? Like in order to, track reliability, look at different kind of failure mechanisms, looking at the overall system response.
Mhm.
And so, this I call the last year the sense of scale. Like if you wanted to simulate the optical performance off of a satellite in orbit tracking a hypervelocity vehicle, like that's a lot.
And you can do it. Yeah.
Yeah. And so you have all this mission stuff.
Good point.
That term gets confusing, and depending on your
Mhm.
specialty, that can definitely put you to sleep, right? And so a lot of times it's I'll just rephrase it as like it's bigger than the one part, bigger than the one assembly. Like this actually has to do something in the room. And so the one topic that we haven't really touched on, and that's the one person that I'm looking at on the screen who hasn't talked yet is Noah. And so
Yes.
from a model based approach to things, a couple of years ago we would go into companies and ask, what's your cloud strategy, right? Because we're making bigger models. How are you going to actually solve that? And the other conversation is, what's your model based systems approach? Like how are you actually capturing your processes, capturing your design, your analysis, your whatever you want to call it, included in that, and making it something useful to actually either create a better product, create better traceability, to find problems before they actually occur. And so Noah, hopefully you're getting ready, including your throat, to talk about what's new on the way, what you're excited about on the SE side.
And thank you for that segue, Doug, because as soon as I asked what else did I miss, I realized I missed model-based systems engineering.
Yeah. No, I was going to send you a message and can you just send me a layup?
What's one of the fastest growing areas of simulation?
And you did it. So yeah, perfect.
So Noah, what are you excited about from the previous two releases?
Sure. Thank you, Doug and Eric, for the great introduction. No, I would say that 2024 was kind of the year of the system, or systems, depending on how you look at it. We saw the release of two new products under the Ansys umbrella of model-based systems engineering. So first and foremost, we saw the release of SCADE 1, which is an all-new, freshly designed IDE and code generator based on the new Swan language. So it's a successor to SCADE Classic, if you will, which is for designing and testing, generating safety critical or mission critical code for embedded systems. Which it's a brand new tool. It's still, in that build up phase, but it's been released, and playing around with it, it definitely has a lot of new, nice to have functionality. A dark mode, like, Christian alluded to in the mechanical suite. Obviously, it's got a brand new code generator with a low level language attached to it. It still has a focus on safety critical sorts of applications. But we're also now seeing a little bit more of an emphasis on non-safety critical or non-mission critical or more, generalized embedded software development. So we're hoping to get a little bit broader there. And we also saw the release of the new Systems Architecture Modeler, or SAM for short, which is an all-new cloud-based systems modeling tool that adheres to the new Systems Modeling Language 2.0 standard. And it really allows you to design and understand really just about any sort of system by designing basically its requirements, its, you can describe its architecture, its inputs, outputs, connections, how it behaves, and then you can eventually connect that downstream to various tools and analyses. So that's definitely big stuff. Super exciting.
Yeah. I like what you said about being the year of systems, because I think that's across the product lines, right? Not just in the system modeling specific tools. We're not Cynthia's not here, but a lot in the kind of rebranding of some of the Speos products as autonomous vehicle simulation platforms, right? So being able to model headlights and being able to model the sensors on an autonomous vehicle, and really looking at optics from a system level standpoint. I don't know if anybody can speak to any changes in optics over the last year, or we'll just have to get Cynthia on at another time to do that. Anybody have anything to add to that?
I don't want to get yelled at by Cynthia for saying something.
Yeah, and we might get it wrong. Yeah.
I mean, we can talk about we can talk about the interconnectivity between the optical tools and the other.
That's the big one,
right?
That's a big one that I've heard of that. Yeah.
yeah. So when it's optomechanical, and I think I'm a mechanical engineer, talk about that. So being able to better capture when you say ruggedize, like you can actually simulate why something needs to be rugged. And so looking at different thermomechanical effects on lens assemblies from that standpoint, and seeing a kind of a tighter integration for that. So simplifying that workflow has been good. And I mean, we Noah hit on a lot of the system stuff, and I feel like we're going to get fined if we don't mention STK, because that's been such that
Yes.
You hit it exactly right. It's been the year of the systems. And there's been one arm that's been kind of the model center, SCADE, SAM aspect, and then the whole STK portfolio for sea, land, and space. Someone just told me what like the acronym stands for one of the products, and I've already forgotten. But kind of a 4D physics engine that you can overlay simulation.
Right.
Stuff on, and seeing, we were introduced to it a couple of years ago, and I've seen enough of it where it's finally starting to click in what it's actually useful for. So, and it's useful for pretty much everything. And so it's, we talk about, introducing real world effects, and that's about as real world as you can get by strapping your simulation onto a 4D solver engine. So yeah, I mean, just talking about the integration of all these different tool sets, and STK plugging into Thermal Desktop, or Tyler, I think we missed the EMA products, and so looking at kind of those charge, or you're gonna have to jump in and save me on this one.
As a charge
what
plus
is the
an
mechanical analogy?
Thank you.
Plus.
Yes. Thanks for letting me only drown a little bit.
You're welcome.
But
The
using those tools to add reality, or kind of look at different space effects for different charge environments, and kind of overlaying that and adding reality to something that exists in space, right? And so it's been a lot of integrations and understanding. When would you use Thermal Desktop? When to use Fluent? When to use IcePack? You use all of them together in order to do different things. And so it's been fun having multiple tools that do different things without having to make gross simplifications and kind of like hack your way to something.
Yeah, I was just looking at a white paper that Ansys put out on that topic, where they were doing optics, thermal, and fluid, and structural vibration on a hyper transonic aircraft that's got sensors on it, right? So how does the radar behave? How does the optical cameras behave? Well, how's the structure behave? And all together in one simulation, or one group of simulations that are connected. It's pretty. That was the sort of thing that maybe 10 years ago we looked at and said someday, but you can do it now. Yeah. Cool. I love it. What else? Anything else before we sign off here? Okay.
Yeah,
go ahead, Noel.
I'll really quickly just throw in a couple other things that I've kind of seen and been excited about. I talked really briefly about SCADE 1, but in SCADE Suite, or SCADE Classic, as it's kind of known, by the users, there is a new Python extension manager that is released in 24R2, I believe. So, if you're doing a lot of embedded software design, maybe you're working with different Python packages, and it can be really difficult to kind of manage across multiple projects that you're working on, right? And so now built into the actual SCADE, user interface, you can pretty much manage all these different Python extensions, whether the public packages, your own internal ones, and you can have multiple different profiles that have, each of them. So that's really exciting.
Yeah.
Yeah. And then kind of still staying on that Pythonic sort of trend, we saw the public release of Pi Model Center as well, which allows you to kind of do that systems approach and enable a lot of different Pythonic automations to control the Model Center tool. So very exciting stuff there as well.
That's a good point. And I love the word Pythonic. I'm definitely going to start using that. I love it. That's great phrase.
It's one of my favorites.
I love it. Who would have thought that Python would become as ubiquitous as it's become? But boy, it sure is everywhere. Yeah. Okay. That's actually a great place to finish, unless anybody's got anything else that I skipped over. Yeah. All right. Well, this is great to have so many of you join us, and hopefully give our listeners out there some excitement about some of the things that are there, and maybe things they haven't looked at. And we look forward to having more in the next release. So does anybody know when 2025 R1's coming out? Is it March?
I think we're like 12 days out.
Yeah.
Oh, it's January. Okay. Yeah. Or February.
Are you sitting down? Good. We got
That's fantastic. Good. So even more to talk about when that comes out, even more. I think another great having all of you on here is hopefully our listeners can get a feel for the expertise and the variety of knowledge that the team has. And like I said, this is just a fraction of our team, and not everybody was able to make it, but great discussion. I learned some really cool things that I'm going to dig into a couple of them. And as always, if anybody has any questions about any of this stuff, do reach out. And if you like what you heard, consider using PADT as your channel partner if you're in our territory, and if not, as your consulting partner, because we'd love to use this expertise to help you guys. So everybody, thanks a lot. Everybody have a great weekend. That was a great chance to get to know so many of our team. I hope you enjoyed it as much as I did. These people and their coworkers are what really make PADT different, and why so many companies who have a choice choose PADT for their Ansys software or to outsource the simulation to us. So we just talked a lot about Ansys, but PADT also sells and supports another simulation tool, Flownex. Flownex is a 1D thermal fluid solver that models complex systems with ease, and PADT has been a distributor of Flownex in North America for just over 10 years, and they have been an Ansys partner for about the same amount of time. Our customers use Flownex to model nuclear facilities, mines, secondary flow and turbine engines, combustors, medical devices, and chemical processing equipment. Every month, we find a new application for this powerful tool. Oh, and not only are they an Ansys partner, you can connect Fluent to Ansys products in co-simulation, or you can send boundary conditions back and forth between Fluent and Flownex. It's also highly customizable. There's way too much to cover in this short advertising, but if you are looking for a system-level thermal fluid tool, we can say that Flownex is by far and away the best one out there. So visit www.padtinc.com/Flownex, that's FLONEX, to learn more, or contact us at info@padtinc.com, and we would love to talk to you about it. It's our second favorite tool in the world, after Ansys, of course. All right, so let's talk about the Ansys stock, ANSS. As of this morning, it's the 22nd of January. It was at 355.61 this morning. So the price has been up and down between 300 and 360-ish range in 2024. As a reminder, Synopsys, when they announced the potential acquisition of Ansys, they offered a price of 390. So it's been sitting under that. The stock finished the year at 337, and it started 2024 at 344. So pretty flat, which is to be expected as the deal works its way through the system. So in Ansys news, speaking of which, we usually don't have any news about the deal, but one bit of news that came out was that I think it was the European Union, I can't remember if it was the UK or the European Union, said, hey, we're not going to approve this merger unless you sell Ansys PowerArtist to somebody else. So they felt that Synopsys and Ansys had identical products in that space and it wouldn't be competitive. So they went ahead and sold PowerArtist to Keysight. That's the same company they sold the optics tool Code 5 to. So that's been done. So it looks like that may be so far the last hurdle. So the timing that we keep hearing is first half of 2025. So it could be tomorrow, could be July, June, who knows? But it's moving forward. Other news, Ansys was at CES 2025 in Las Vegas, as was PADT, and they showed off a lot of products there, really focusing on their new AI offerings, their automotive tools, and their electric vehicle stuff. And it was really a lot of great examples of how some famous companies like Ferrari use Ansys products to make their products better. So that was kind of a couple news stories on that. And then they did a bunch of press releases as usual about partnerships. It's good stuff. I mean, this is real world people using Ansys to make a difference in how they make their products, but nothing, worth pointing out that's like unique, like some cool company or especially cool company or anything unique or special. But Ansys is now everywhere. So it's kind of partnering with a company is not that big of a deal anymore, right? Because they do it all the time. On the PADT news front, the only big news from PADT since our last episode was really not about Ansys. It's about 3D printing. We announced in a press release that we're certified to train people who train people in 3D printing. So we went through the process of getting a government certification for that so that people can use federal funds to pay for that. So we're really proud of that. It's really important from a workforce development standpoint and to help our customers use the Stratus products we sell better. So that was the only big news we had. Let's go ahead and go back to the Ansys world and talk about their blog. So as you know, if you're a regular listener, I picked 3 stories since the last podcast that I like. One that I really liked was a company called CircLeg, which makes basically artificial legs. It had an article called CircLeg Empowers Amputees Through Simulation. So this has been a fascination of mine for a long time. I think it's really cool. It's a great use of a lot of different technologies, and I love to see Ansys used in that. So that's of interest if you want to check it out. Probably the most important one is called Accelerating CFD Simulation with NVIDIA's GPUs on-premise and cloud solutions. So basically what this is they looked at doing some new benchmarks with the new NVIDIA GPUs. And what happens not if you add one GPU, but what happens if you add multiple GPUs? So it's parallel between GPUs as well as parallel on the GPU on a given GPU. And this is Ansys Fluent. It's CFD. This has been around for a while, quite heavily used on the mechanical side, but on the CFD side, it just keeps getting better and better. It's pretty impressive. Couple different benchmarks, but if you go to 8 GPUs, they can be 5 to 6 times faster than a single GPU. So if you're doing big models, it can really pay off. So if you're running CFD, large models, take a look whether you plan on doing it in somebody else's cloud or on-prem. It's good to know how many GPUs do you want to add? How do you want to run that? Also, I really recommend you check out a blog post that introduces a new member of the Ansys family, Hans. So Hans is a anthropomorphic FEA model for LS-DYNA of a human body. It's pretty cool. The article is called Meet Hans, the human body model, helping make cars safer. In the past, you would basically have to get a third-party model, and they were kind of coarse. I mean, getting better. But this one is really advanced. It's got a skeleton, it's got brains, it's got organs. So it's not just a mass. You can actually see what the loads are on various parts of the body. Ansys offers a product called Ansys Hands, HANS. So even if you don't model crashes and such, if you're a simulation person, you're going to love this. So check out that blog article, Meet Hands, the human body model helping make cars safer. It's pretty cool stuff. Brains are included. On the PADT side, we did a post on our visit to CES in Vegas. So check that out to see our take on the event. Our sales team and some of our technical team went to that. And then Alex Christian posted a post called Applying an Average Temperature in Ansys Mechanical. And it summarizes how to say, if you I want a surface in my model to have an average temperature, but I want to have a temperature gradient on that surface. Now you can do that. And he explains how to do it. And it's a pretty good article. I also put out a couple of articles on the Microsoft side of things, not Ansys related. How to create tasks in Planner using a flow, an automation flow in Microsoft, and some more Excel stuff. So check that out. We've always got cool things on the blog. Webinar wise, we're still working. A lot of the team actually is at the sales kickoff event, and I think it's in Florida this year. And we learn at that what should we get excited about? That's when the product managers come out and tell us what's awesome and cool in the coming year. So when they get done with that, they're going to come back and figure out the schedule for our webinars. So stay tuned to see what webinars we've got. And then as far as PADT events go, we want to take a look at those. I'm at the one right now, which is the Arizona Photonics Days down in Tucson. We talked about that at the beginning of the podcast. The next event we'll be at is I and some other folks from PADT will be in Anaheim for what is now called MD&M West. It's had a bunch of names over the years. There were multiple shows in one venue. They're just calling the thing MD&M West now. It's the design. It used to be called the Pacific Design Show. Love it. Go every year. I'll be there February 4th through the 6th in the PADT booth, which is 4047 at the Anaheim Convention Center. So please do show up and say hi if you're there. At the same time, here in Phoenix is the 2025 Transformative Vertical Flight Show. It used to be called the Helicopter Show. Now, with all the other vertical flight options out there, they just call it the Vertical Flight, Transformative Vertical Flight, TVF. We'll be in booth 312. And it's here in Phoenix. So every other year it comes back to Phoenix. It'll be in the Phoenix Convention Center this year. So check that out. PADT folks will be there if you're in the vertical flight area. After that, we go to March. We'll be at the Arizona Space Summit in Colorado Springs. I love that event. Please stop by. No, I take it back. Wrong event. Arizona Space Summit is Arizona Space Summit. It's not Colorado Springs. It's in Tempe. It's hosted by ASU, and it's basically a gathering of everybody in the Arizona space ecosystem. It's a one-day event on March 20th. Got those mixed up with the next event. So do check out the Arizona Space Summit. And then we hope to see some of you in April 7th through the 10th to be exact, at the 40th Space Symposium. So we'll be hosting the Arizona Space Industry booth again for the 2025 event. We're in booth 640. Stop by and say hi at the Broadmoor in Colorado Springs. We'll also be out in Austin on June 9th through the 11th at the Tech Connect World Conference for 2025. So this is for the SBIR, STTR world, commercializing technology. So check that out. That's in Austin in June. Also in June, we'll have a team at the Turbo Expo, which is in Memphis this year. And then the other event that we have on our calendar is an Arizona event for the Aerospace and Aviation Defense and Manufacturing Conference, which will be in July. So lots going on, lots of different things to do. Hope to run into some of you at some of those events. And always check out our website. If you go to our website, hit the About menu button and then find events, you can see all the stuff we're doing. So that's it. Thanks again for listening to another one of our episodes of the All Things Ansys podcast. Don't forget to subscribe to our newsletter, which has more information at www.padtinc.com/opt-in. And please spread the word about the podcast and subscribe if you haven't already. It helps us, rate us, subscribe, all that stuff the kids say, the influencers say on their TikTok and YouTube videos. Do it for us. Help us get our numbers up. So as always, don't hesitate to reach out. Thank you for joining us for the All Things Ansys podcast, episode 133. As a reminder, this podcast is not affiliated in any way with Ansys Inc., and the opinions expressed are those of the people on the show only and not of their current or former employers. For more information, visit www.padtinc.com/blog, and please share your thoughts and questions through an email to podcast@padtinc.com. See you next time.